All right, let's talk about 4.2 graphing exponential functions. And this is a quick one. So there's a shortcut here, and I want to talk about that. So we can go through all of the different ways to graph this, and there's all kinds of different things to think about. But this is the six-step process to do this no matter what. So here's the shortcut to graphing an exponential function. So to graph a function of the form f of x equals a times b to the x minus c plus d. So you may see that this looks kind of, but not quite, but kind of like the general form of an equation. We've got an a, a b, a c, and a d in here. And these things all behave just like you think they are. Just like you think they do. So I'm not going to spend any time on them. We've already talked about it. If you need more review, hey, go back and watch 1.5 again. But notice that a can't be 0, b has to be greater than 0, and b can't be equal to 1. That's all the stuff that we knew from the last thing, except we've also now added in this minus c plus d. And that's just translating it around on the graph, just like you think you would. So x is a real number, and c and d are just real numbers. All that we need in order to do this are just 2 points and the equation of the horizontal asymptotes. And I'm going to say this a few times. An exponential function has a horizontal asymptote. An exponential function has a horizontal asymptote. An exponential function has a horizontal asymptote. Please try and remember that. We're going to get to logarithms next, and don't worry, they're just as easy as exponentials were. They'll have vertical asymptotes. They're the exact opposite of exponentials, in fact. They're inverses. Spoiler alert. However, the steps to graphing work like this. You plot the horizontal asymptote by drawing the line y equals d. So the first thing you need is the horizontal asymptote. Go draw the line y equals d, whatever this is. If it's plus 7, go up to 7 and draw a horizontal line. If it's minus 6, go down to negative 6, draw a horizontal line, whatever. That's the first step. Now, you're going to choose a value to plug in for x such that x minus c equals 0. If you solve this for x, you add c to both sides, you get x equals c. So you're going to choose a value for x so that x minus c is 0. That is, you're going to choose c. So ignore the sign, just come look at c, you're going to choose that number. You want the entire exponent to be 0. That is, we need 2 points. So we're going to need the coordinates for 2 points. Well, the easiest point to get is what happens if the exponent is 0. Well, if x minus c equals 0, like this, if x minus c equals 0, then b to the 0 is 1. And you just get f of c, which will always be, in this case, just a plus d. But I didn't want to generalize it that much. So all that you do is you just pick a value so that x minus c equals 0. And then you plot the first point. It's whatever you chose for c, comma, f of c. That's it. All right? And then you determine if b is a proper fraction or otherwise. So if your base is a proper fraction, 1/5, 2/9, 17/26, then it's a proper fraction. Otherwise, in our examples, it'll be a whole number, but this works otherwise as well. So it's either between 0 and 1, so it's a fraction, or it's bigger than 1. If b is a proper fraction, just like this first thing, then you're going to choose a value to plug in for x such that x minus c equals negative 1. If you solve this for x, you add c to both sides, and you'll get plus c minus 1. So x is c minus 1. So you plot that point. If x is negative 1, that is, x minus c is negative 1. If your entire exponent is negative 1, so let's say that your base was, for example, 1/5, and you choose it so that you get 1/5 to the negative first power. You choose a value so that you get this. This is 5. Because remember, anything to the negative first power is just reciprocated. That's what it means. It is literally 1 over this. 1 over 1 over 5 is just 5. This is how this works. So this is why we're choosing this to be negative 1. This is my strategy for choosing this. So we're just going to choose so that it works. And we'll do an example here in a moment. But I just wanted to give you that quick little example. If b is bigger than 1, you're basically done. You just choose it so that the exponent turns into 1, so that you raise whatever this power is to the first, and that's an easy thing to do. So what we're trying to do is keep this as easy as possible for ourselves. So the 3 numbers that we're trying to turn it into, the first one is always 0, and then the second one is either going to be minus 1 if it's a fraction, so that we can flip it and turn it into a whole number, or if it's a whole number, the first power, just keep it like it is. So here's everything that you need to know. Once you have those 2 points, You just trace the graph approaching the asymptote that goes between those points. So I want to look at a couple of examples real quick, and we're going to look at them on the website that we do this on, and we'll see what I mean by all this. So get this down, write this down, so that you can go through these steps yourself and see if you can't figure this out. So pause the video, get this down, and then we're going to go on to another example. So the first example asks us to graph the function f of x equals 5 to the x minus 2. So going back to all of that stuff that we just said, we're going to write down and go through those steps. So the first thing that we're going to do is we know that there's going to be a horizontal asymptote at y equals negative 2. So we will graph that. And we're going to actually do this on the computer here in a second. So this is information that you'll need to write down. So write this down so that we can keep all this in mind. So we're going to graph the function f of x equals 5 to the x minus 2. So we get y equals negative 2. And now we need 2 points. So the first point, you'll notice that this number right here is a whole number. B is greater than 1. 5 is definitely greater than 1. So we're going to choose a C so that this up here is 0. We're going to choose an X rather so that this up here is 0. Well, C is 0. We're subtracting 0 or adding 0, whichever way you want to think about it. So if I just raise this, that is if I plug in the point, so here's point 1. Here's point 1, okay? Point 1 is we're going to plug in 0, and we're going to get out, well, when I plug in 0, I get 5 to the 0 minus 2. The reason I plugged in 0, that is I found f of 0. I plugged in 0, so there's 0, and then what we get out is f of 0. So 5 to the 0 is, well, 1. That's why we plugged it in. 1 minus 2 is negative 1. So we get out negative 1. So that's the first point. And now we just need another point. So the first point is always plug in 0, see what happens. Or plug in an x value so that your entire exponent is 0. In this case, it was 0. If this were x minus 3 up here, you would have plugged in 3, because 3 minus 3 is 0. And this would have been 3, comma, whatever happens when you do that. You want the exponent to be 0. You don't always plug in 0. You want the exponent to be 0. In this case, x was 0, so we just plugged it straight in. And then in the second case, it's one of two cases. Either 5 is greater than 1 or it's a fraction. Well, 5 obviously isn't a proper fraction. It's 5 over 1. That's an improper fraction. So we're just going to choose x equals 1. So we want to choose a number so that when we plug it in up here in the exponent, we get 1 out. So if this were x plus 3 up here, we would choose negative 2. So we would come down here and say negative 2, comma, whatever, because if you plug in negative 2, you'll get 1 overall. That's what we're trying to do, get 1 overall up here, just because it's easy, because that's easy to do. So what we have now is, well, what number do we plug in for x so that there's a 1 in the exponent? Well, it's just x, so we obviously just plug in 1. And if you plug in 1, we're finding f of 1. So this is 5 to the first minus 2, which is 3. 5 to the first is 5. 5 minus 2 is 3. So 1 comma 3. So there are your 2 points. So remember those 3 pieces of information. Write that down. Your horizontal asymptote is at y equals negative 2. Your first point is at 0 comma negative 1. And your second point is at 1, 3. And now we're going to go plot those where we need to. So here's the exact same thing. It says graph the function 5 to the x minus 2 on the axes below. You must plot the asymptote in any 2 points with whole number coordinates. We needed whole number coordinates. So the method that I gave you will always give you whole number coordinates. That's why we did it the way that we did. So it's going to say, first, is the asymptote vertical or horizontal? In this case, the asymptote is going to be horizontal because it's an exponential, and it's going to give it to you. Here it is. It put it at negative 11. That's not where it goes. Look back at your notes, and you'll see that this thing goes at negative 2. I'm just going to click on it and drag it up here, drop it off. And then I need to plot the 2 points, 0, negative 1. So I'm going to move my 0 down to negative 1. And then I need to plot the point 1, 3. There's the point 1, 3. There's your answer. That's what we're looking for. If you plot that, you're good to go. All right? So that's how you do it. That's all that there is. If you need to see it again, hey, rewind me for a second and look at that. But that's all that there is to that. A little bit of work and you're good to go. So let's look at the second and final example here. We want to graph the function f of x equals 3 times 1/3 x plus 5 minus 2. 1/3 to the x plus 5th power minus 2. Cool. No problem. We can do that all day. It's the exact same thing. You're going to have a horizontal asymptote. That's the first thing you take care of. Just look back at your list. And by all means, pause it. See if you can figure out the horizontal asymptote and the 2 points. See if you can figure that out. If you can do it on your own, then you know that you're good to go. All right, so pause the video, give it a shot. But we're going to go ahead and do this. So your horizontal asymptote will be the horizontal line rather, y equals -2. I just took this, literally that. That's it. So now you need a point. So your first point, point 1, okay? Your first point is going to be a point so that you want x plus 5 to be equal to 0. We want x plus 5 to be equal to 0. So for point 1, we want x plus 5 to be equal to 0. That is, we want x to be equal to -5. So we want to plug in -5. So our first point is going to look like, well, we're going to plug in -5. What happens when I plug in -5? Well, let's plug in -5 up here. As we're going to find f of -5. And that'll be what this is. This point right here is f of -5. Okay? It's going to be an actual number. We're going to write that, but that's what that is. So f of -5 is, well, that's what happens when you plug in -5. So it's 3 to the 1/3 times -5 plus 5 minus 2. This equals minus 2. So this is 3 to the 1/3 to the -5 minus 5. That's 0. That's why we chose this to be -5. We could have plugged in any point if we wanted to, but remember, we're being asked to do this for whole numbers, so this is going to give you nice whole number outputs. Minus 2. And 1/3 to the 0th power is 1. That's why we wanted this up here to be 0 the whole time. That's why we chose -5, so the whole thing would be 0. So this is 3 times anything to the 0th power is 1, minus 2. And obviously that is just 1. So we get out 1. So point 1 is 5, 1. Now, point 2. And then we just do what we need to. So point 2. Now, what we need to do is come in here, and we need to look at this thing again. So b is now obviously a proper fraction. You'll notice that it's 1/3. That's definitely between 0 and 1. So what we're going to do is we're going to choose a value so that x plus 5 equals -1, equals -1. Specifically, we're going to do this so that this entire exponent, x plus 5, can be -1. If we're raising 1/3 to the -1st power, then this is just 3. 1/3 to the -1st is just 3. That is, 1/3 to the -1st power is 1 over 1/3. And when you divide by division, you do 1 times 3 over 1, which is 3. That's what we're doing. That's why we want this to be -1. We want to force that. This is the sort of situation we want. We could plug in any point you wanted, but it's not going to give you a useful whole number point that you can easily graph. You could pick any x you felt like, any 2 x's you felt like, run them through, get the 2 points, and do this just as well, but they're not going to be nice whole numbers. This approach gives you nice whole numbers every time, and it's as easy as I can possibly make it. So we're just going to choose, like I said earlier, we're just going to subtract 5 from both sides, and we'll get x equals -6. And that's it. X equals -6. We subtract that from both sides. So we're going to plug in -6 like that, and we're going to get out f of -6. Okay, we're going to get out f of -6. Well, f of -6 is run -6 through this. So this is 3 times 1/3 to the -6 plus 5 minus 2. Well, we chose -6. Again, we could have chosen any number we wanted to, but we chose it to make the final result as nice as possible. That's the reason we're choosing numbers like this. So this is going to be 3 to the 1/3 to the -1. 3 times 1/3 to the -1st power minus 2. So 1/3 to the -1st, as you've already seen at the top of the screen, that's just 3. So this is 3 times 3 minus 2, and that's obviously 9 minus 2, which is 7. So you get out the point -6, 7. So keep that in mind. There's a horizontal asymptote at y equals -2. The first point is -5, 1. The second point is -6, 7. That's all that there is to that. So let's look at it. So what we've got is the function f of x equals 3 times 1/3 to the x plus fifth minus 2, we're supposed to graph it. So we've got all the stuff that we're used to here. So let's look at this. So the asymptote is horizontal. It's a exponential function. Even though this is a fraction, it's still raised to a power. We know that our horizontal asymptote was going to be at -2, so I'm just going to go ahead and click and drag this on up here. Our first point was at -5, 1, so -5, 1 right there. And then our second point was at -6, 7. So right there's -6, 7. There you go. That's exactly what this entire thing looks like. So that last step that you see is just draw a swoopy line through this. You know that it has to be positive. You know that it has to be positive, and I'll leave it to you. It's literally your think about it. I'll leave it to you to figure out why we know this is positive. Go back in your notes and look at it. We did talk about that in 4.1. But we know that it's going to be above this, and it's going to have to go through these 2 points and approach this asymptote, but never touch it, and definitely never cross it. So this is what you're going to end up getting. So that's all that there is to this, and that's all that there is to this entire video. So I hope that you learned something. Go try a bunch of these yourself, see what you can do, and as always, if you've got any questions, do not hesitate to ask. Good luck, y'all. See you in the next one.